Hi everyone, my name is Sandy. Here we're going to be investigating the homework journal problem for section 2.1. So here is the problem, or the statement. Estimate the instantaneous rate of change of px equals to 5 over x minus 5 at the point x equals to negative 3. So in this statement, I saw several phrases that really caught my attention. First, we're trying to look for the instantaneous rate of change at point x equals to negative 3. So for the statement, we knew that we're going to be mainly looking to the instantaneous velocity for this function. At the particular moment where x equals to negative 3. How do we solve this problem? Firstly, I would like to remind everyone with the formula. Formula for the average velocity where average velocity equals to change in distance over change in time. So in this case, we could also seek the information of the distance we're going to be getting from the function px equals to 5 over x minus 5, where we're going to simply plug in our x values right here. So we're having our first x value, right, which is x equals to negative 3. And we're also, according to the formula for average velocity that we need to have, or we need to find the differences between 2 points. So the first thing we need to do is select n or a value, an x value that is as close as it could be towards negative 3, because we will like our value or instantaneous velocity to be as accurate as possible. So here is my x value. I'm choosing negative 2.99999. As we all know that the more decimals that we have, more accurate the problem could be. So here is my second x value. Then, since we know that distance is going to be this function, and also we have our time. Next, the second step is we're going to be looking for the average velocity between these 2 points, between these 2 x values. How do we do it? Firstly, we're going to be following the formula. Average velocity equals to change in distance, right? Over change in time. where this function is going to be the function that we'll be using to look for the distance. So we're going to be plugging our x values into the function for our first distance. So 5 over negative 2.99999 minus 5 minus, because we're looking for a difference, so there must be a subtraction. 5 over negative 3 minus 5. So it is just a personal habit that I would like to put parentheses when there is a negative number, because I don't really want to make any errors during my calculation, because sometimes we would easily forget there is a negative sign, which it'll cause a lot of problem, or it'll even lead to a wrong answer eventually. And for the bottom part, we're just bringing down the time, because as we know, x value refers to the time. So negative 2.99999 minus negative 3. So in this case, it'll be important or necessary to put down parentheses, because there is going to be a sign change right here. Negative, negative, it's going to be a positive. So next, I am just going to put the whole equation to my calculator, and this is what the calculator tells me. It equals to negative 62500 over 79999, which approximates into negative 0.078121, which is very close to our actual answer. And here is our instantaneous velocity for of this function px equals to 5 over x minus 5 at the point x equals to negative 3. So here are some tips. First, you would like to choose an x value that is close, super duper close to our studied value. Next, we're going to be utilizing the formula for average velocity, which is change in time distance over change in time. And then number 3, you'll simply plug in the x values and pay attention to the sign changes. Better to have a parentheses. So that's all. Thank you so much for listening.